Welcome to Algo Guru. In this video, we are going to look at some more of the bit manipulation problems. Let's jump into the problem straight away. The first problem we are going to look is how to find the power of a number. The C++ library already had a function called POW. It's all in lowercase. You can use that. And how can we do that using bitwise operators? It's not that tricky. So let me actually write a function myself. So it will be something like this. It will take like two arguments which are of type double, and it's going to return a double. And I'm going to set a result which is going to be initialized to 1.0. You basically need that in order to do it. So let's go into this, and then I'm going to declare a variable called power, which will have y, and then I am going to have a while loop, and I will go through the while loop making sure that power is greater than 0. So what will I do with power? Okay, so I'm going to, like, at every point, at every iteration of the loop, I am going to do a right shift of the power. So what that will do is that it is going to reduce this value as we keep going. So that's what this is supposed to be doing over here. And then I have to also do something like x multiplied by x. And now there is another condition where I'm going to look whether power and whether the least significant bit is a set bit, whether it is 1. If it is 1, then what I'm going to do is that I'm actually going to set the value of the result to that one. So how I will do that is basically result into x. And then at the last step, I can basically return result. So there is a much more cleaner way to do this. Let me do it in that way, like, okay. So this will be like much less complicated. So what we can do is that use this dummy test function and see let's see what this 2 comma 3 and end L, and then we will have like 8, and then we will have like 2. Just do it one more time, 8, and then we will pass 2, and let's see what it comes up with. So here it is. 2 to the power 3 is 8, and 8 to the power 2 is 64. So we got it correctly. So let's take a look at this function one more time. We have this result variable initialized to 1.0, and then have the power initialized to y. That is the power raised to. And then go through this while loop. And whenever the least significant bit of power is set, then that's the only time when the result is actually going to get initialized or actually getting updated. Every time it's set, it is going to update the result. And other than that, it is just going to keep multiplying x with itself, and then it is also going to right shift power so that it can actually come out of this while loop. when the power becomes 0 or less than that. So basically power will become 0 once all the bits are being like pushed to the right side, and then just return the result. That's all for power off. The next one is reverse an integer. Reverse an integer is like much more easier thing, straightforward thing. Probably most of you might have already familiar with how this is being done. So it's a pretty easy thing to do. Let me do something like this again, like I will do a result over here, and then I will have another while loop x. So whatever is the input argument, that is going to be x, and that's going to be the condition for the while loop. And then for the result is basically going to be like result multiplied by 10 plus ax module of 10 and x module x divided by 10. That's pretty much it. And then return result. So here is a small trick over here. So what if the value is a negative number? Like for example, I have like two test cases here. So the first one is pretty straightforward, 1, 2, 3, 4, 5. So the output has to be 5, 4, 3, 2, 1. So this is just the reverse. But what if it is a negative value, negative 8, 4, 7, 4, 2? Then the result has to be a negative 2, 4, 7, 4, 8, right? And this function that we have written over here is definitely not going to do that. So we need a better way. So what will be that? So what we are going to do is we are going to get the absolute value of x, and then just replace all these x with this num. It's pretty easy to do that. And let me just do like a brackets over here just to make it look clean. As you know, like the first time result multiplied by 10 will be 0 plus num module 10, which will be, in this case, it will be 5 on the first loop. And then the next time num is going to be divided by 10. So num will become 1, 2, 3, 4. So, okay. So here is the trick. When the input is a negative number. So if num less than 0, you want negative result, or else you just want result. Result. That's all you want. That's all you got to do. Let's run a okay. Let's run a test case on this one. Reverse 1, 2, 3, 4, 5, and then reverse what, like negative something. Negative 8, 4, and then here it will be 1, 2, 3, 4, 5. Let's run it and see what it is going to bring up. Okay, so we got like 1, 2, 3, 4, 5, which is 5, 4, 3, 2, 1, and for 8 and 2 it is 2, 4, 7, 4, 8. Okay, so let me first fix this. And we got a problem over here. So, okay, so negative. All right. All right, so I had a small problem here, like rather than doing like x, I did like num. So num was already an absolute value, so it had taken away the sign. So when I put like x less than 0 and then do like a negative result and result, it's going to work perfectly. So that's pretty much it for reverse. All right, the next one we are going to look is palindrome. Given a number, check whether it is a palindrome. So the first one, 1, 2, 3, 2, 1 is a palindrome because from this side and also from the right side, whether left or right, is the same number. But the second one, 8, 8, 2, 3, 2, from left and right, it is totally two different numbers. So this function is going to return a Boolean saying true or false. So what will be this function looking like? So I will have like a long being passed into this particular function is palindrome. The trick here is that we are going to simultaneously look at the left and the right. How can we do that? We already know because we did the reverse before. The easiest thing to do, the very easiest thing to do, just like do the reverse of the given number and see whether it matches with the input number. If it matches, then it is a palindrome. If it doesn't, it's not. That's the easiest thing to do, or you can even convert it into a string and do the comparison. So those are like pretty easy things to do. But the real way it can be done is, like I said earlier, we have to keep looking at the numbers at both ends. So we will start with the this one on the left side and the one on the right side, and then we will go in 2, 3, 2. Again, look at both sides. It's 2 and 2. It's same. If at any point if it doesn't matches, then it will just come out of the loop. So that's the easiest way that this can be done. Okay, so the first thing that we are going to do is that we have to find like how many digits, how many digits are there in this number. So that's the first step that needs to be taken. So for that, what we are going to do is that we are going to use this particular function, which is called floor. And this is again from the C++ library. It has this function called floor. And then you use the log10, and then you add a +1. And this is going to give you the number of digits in that input number. So that's the first thing. And the second thing is that you have to find the mask. So what is this mask? So this mask is calculated again using a POW. We can actually use the power of function that we already written, but in this particular case, I'm going to go with whatever the standard library is going to provide. So I come here, I'm going to create this nums -1. So this is basically like 10 to the power of something, right? 10 to the power of 3 or something like that. Why we are doing this? So this mask is what is going to be used to find the leftmost. The rightmost, we already know it's very easy because we already did that with the reverse. It's just like modulus of 10. You get the rightmost. But for the leftmost, it's a little bit tricky. We have to find the number of digits, and then we have to come up with a mask, something like this. And that's exactly what we are doing right now. All right, so once we get both of this is a little bit straightforward. Like we will just come here and okay, so we are going to do like a for loop. So we don't go through the entire nums because at every given point of time, we are going to shrink it on both left and right side. So it's like a log n kind of thing. So it's the same, like if you write a function in a string or something, it will be the same. You don't go through the entire string, you just do half of it. So that's exactly what this particular line is going to do. And the next line, I need to have a condition where I am going to check on the leftmost and the rightmost. Okay, so it will be something like this. So this is the leftmost, and what will be the rightmost, which we already know. And if it is not matching, we know that we need to just return false. That is not the case, so that is at the end of the thing. We are going to return true. So now we need to have like additional conditions like, okay, so what are we going to do here? On this line, it's again like we are going to like remove the leftmost or the most significant bit. And here we are going to remove the least significant bit or the rightmost. And then we got to do one more thing. This mask we need to like reduce every time. We need to like keep reducing this thing because the number is getting shrunk and shrunk. So this is like a very key component as we keep reducing the mask. Well, let's come here and let's run this and see what we are going to get. 2 1. All right. All right. All right. All right, so what we got is palindrome 12321 is 1 and 84742 is 0. That's it for is palindrome. Just take another look. If you are still confused, always come back to the video and take another jab at it. Well, the next problem that we are going to take a look is intersection of rectangles. So in this particular case, I have drawn something like this over here. It's not the best picture. And then again, I marked like 2 rectangles, one with this the blue markers here. So okay, so it's not much fun like clicking over there. Okay, so you can see like whatever that you see here. So this is like one rectangle. It's marked in blue, and you can see like the coordinates are like 1, 2. So 1, 2, and the width is 3. So it starts from here, goes all the way to 4, and the height h is equal to 1, which is the height over here, that is going up to 3. And the second one is this one, marked in red. So 3, 2, x is 3 and y is 2, so that is the starting point, and the width is 2 going up to 5 on x-axis, and going up to 4, that is the height is equal to 2, so going up to 4 in the y-axis. So what is the intersection point of these two? This is the intersection point. So this point where it starts at 3, 2, and there is a width of 1 and a height of 1. So that's exactly what we need to find out. And we could be given like 2 rectangles which are like totally different. So one would come somewhere here and another may come somewhere here. So there is no intersection point. So we need to find whether there is an intersection point. If there is an intersection point, we will actually give the intersection point like with the x, y axis and then we will also give the width and height of that intersection. And for this particular example, this is the intersection that we need to find. It's a very simple process, and this problem doesn't have a lot of bitwise operators, or I mean, in fact, there is nothing like really bitwise or anything like that. But this is a very tricky thing, and it's kind of like a medium question, or maybe if you think about it a little bit more, it could potentially be an easy two. So let's jump into the code and let's find out like how to find this particular intersection when a function get an argument with these values x comma y comma width comma height. So it will get like two rectangles like that and find whether there is an intersection. And if there is an intersection, then output the exact intersection point, like what is being shown right over here. Let's jump into the code. All right, first thing first, I declared a structure like this structure called rect, and it has these x y axis, and rather than putting like a width, I just put like w, and for height I just put like h, and I have a constructor for that, so which is going to initialize everything. All right, so what I'm going to do over here, so I need like two functions. Ideally it is going to be like one function which is going to return a rectangle, and I'm going to pass two rectangles to this particular function. All right, so that is one thing that I'm going to do, and on top of that I will need also like another function which is again going to take the same arguments, and then this is the function which will return whether it is an intersection, and I will call that function right over here, and then pass r1 comma r2, and if it is not an intersection I will do something, and if it is an intersection I will do something. So if it is not an intersection, let's look at that particular possibility. Like if it is not an intersection, what I will be doing, I'll be like returning like something like 0 comma -1, something like that. So yep, so this is like an error condition, like 0 comma 0 -1 width -1 height means basically there is nothing. And here is the trick. So how are we going to do this? So let's start with this, like let's look at the x value. So we will look at r1x. Is that going to be less than r2 dot x plus r2 dot width? And so this is going to be a pretty large and that we are going to deal with over here. Okay, so again, like r1 dot x plus r1 dot width greater than equal to r2 dot x. And now just jump down here, and then we will do the same for r1 dot y less than or equal to r2 dot y plus r2 dot height. And r1.y plus r1.h greater than equal to r2.y. That pretty much covers everything. So if the and everything passes, then it is going to return true, or else it will return false. So that's all that we need over there. So we are going to consider that, okay, so for this example, it's going to return true. So what next? So if it returns true, we need to create another structure, a rect structure, right? How will we do that? All right, it's pretty simple. So we are going to look at r1.x, then r2.x. So that will be the x value, whichever is the max. That's what we are going to get. Max of r1.y and r2.y. So that is what we are going to get, like for the x and the y values. That's pretty much it. Okay, so next thing that we want to do is that we need to get the width and the height. So let's see how we can do that. Okay, so for the, let's see, so for width, let's start with width. What we are going to do is that we are going to get the mean value of r1.x plus r1.width, and then we will get like r2.x plus r2.width. Then we are going to subtract that from max of r1.x, r2.x. So let me like just copy paste this whole thing, because in the next step what all we are going to do is that we are going to do the same for like y, h, y, h, and then y, y. That's pretty much it. Let me just quickly run this program and see whether it's going to run without any errors. Yeah, it's happy. So the trick now is to find, okay, so R1. Let's go back to our example. So this is what it is. X is equal to 1, y is equal to 2, width is equal to 3, and h is equal to 1. 1, 2, 3, 1. Okay, 1, 2, 3, 1. All right, so the next one is going to be R2, and this is going to be 3, 2, 2, 2. Okay, so this is going to be 3, 2, 2, 2, 3, 2, 2, 2, 2. All right, looking great. So now we will have like a rect R3 is intersection R1 comma R2. Alright, and then we will try to print x is x is equal to R3. So let me like just pause the video here and write everything, and I will come back so that I can keep this video pretty short. All right, guys, so this is it. I'm going to print X, Y, W, and H. So let me run this program for this particular input. And this is what I get. X is 3, Y is 2, width is 1, and height is 1. And that's exactly what we got here. So this is the one. This rectangle starts at 3, comma 2, and it's a width of 1 and height of 1. So that's pretty much it. So this basically going to cover all the bit manipulation problems that I was intending to do. And we covered like I think probably somewhere like around 10 problems, which I think is like a pretty good one. And you are always welcome to look into more stuff going forward. And having said that, I will see you in the next video, and we will pick up another major topic, one of the data structures, and then we will go through a bunch of problems. Thank you.